Hello, welcome to the workshops of AB incubators. Today we're going to show you how to program and set up an itron32 microprocessor. The microprocessor is fitted to a number of machines, mainly the AB New Life 75 Mark 6 Professional. It's also fitted to some smaller Start Life machines. It's fitted to the multi-life range of game setters and hatchers. So it's a fairly widely used machine. But today we'll run through the basic programming and setup for the New Life 75 Mark 6. Okay, there are two levels of programming. The first level we get to by pressing and holding the P button, which is the left hand of the three buttons. Okay, it'll display AL. For the moment we'll ignore the first few parameters because they would reset when we change some of the others further down, so we need to get the other ones right first. So you then repeatedly press and release the P button until you get to the parameter Y0. There it is. Okay, Y0 is an entry into the second set of parameters, so you then press and hold the P button. Okay, C111. This is the first of the configuration parameters. This is defining the type of sensor that you have set and connected to the incubator. This particular incubator uses a PT100 and the code for that is 001, so that is correct. If it's incorrect when you come to it, you can alter it by pressing the up buttons or down buttons. As long as you get back to 001, that's the parameter you need. Okay, press the P button again, it'll take you to the next one, which is C112. This defines the readout on the controller. With a value of 1 as it has now, this is degrees centigrade with 1 decimal point. By taking that value up to 2, you'll have degrees centigrade with 2 decimal points. By putting it to 4, it'll change you over to Fahrenheit readout with 1 decimal point, and changing it to 5 will take you to Fahrenheit with 2 decimal points. Okay, that's timed out now because I've been talking and not pressing buttons. So we'll just go back in, again flicking through the parameters till we get to YO. Press and hold, take you through into the second set of parameters. C111 we've done, C112 we've done, C113. C113 is the assignment of the outputs. So basically the default value is 20, which tells the controller that the heater's on output 1 and the alarm is on output 2. So that's very straightforward. C114, a little more complicated. C114. This is basically the ramp function for the machine, i.e. how quickly it comes up to temperature. That is balanced against how well it maintains its temperature. So with microprocessors, it's a balancing trick to get them to come up to temperature quick enough but then control well once they get to temperature. 5 would be the default on that. C115, this is a ramp function also, which we always set to 0 as standard. Okay, we'll now work through the rest of these. C116 onwards are not used, they're all switched off until you get to SPL. This is the lower limit of the input you can have. So the lowest set point you could have on this machine would be 0.0 centigrade. That's because the machine would struggle to maintain temperature anything above 0. So the next one, SPH, is the highest set point you can put in. Unusual for anyone to want to go above 40 degrees. Obviously that's going to kill your eggs, so that's set to 40 just as a default. By bringing those two to 0 and 40, you reduce the span the machine can work over and increase the accuracy. Offset is the calibration feature for the machine. We'll come to that later in another video. That really is once your machine is up and running, you then need to calibrate, and that's the parameter you use, the offset. Okay, hysteresis. The hysteresis is to do with the control. Again, it's one of the parameters that is very variable. The value of 1 that we put in is what over the years we have found to be the most stable input value. so that stays at 1. Press the P button again will take you into the second set of parameters now, which are the actual configuration for the way the controller is tuned to get the best results. AL is the alarm. It's set at the moment to trigger at 0.5 degrees above the set point, so it will track with the set point. If you change the set point, this will always remain 0.5 above. You can alter that up and down. If you go much below 0.5, you'll find that the alarm will trigger intermittently because of the natural variation in the machine. PB1, this is a proportional band. This is the amount in degrees centigrade that the controller can operate above and below the set point. So if it goes plus 0.1 or minus 0.1, it should control within that zone. Press the P button again, comes to DT. This is derivative time. This is a time which is one of the major controlling factors in the machine. Again, this can be altered. This can go up to 400-500 seconds, but it's not, not useful to change this one too much. You really want to leave this one where it's set factory. The DT that we always put in the factory is 2. So if we change the DT now to 2, that's where we would always set them. By pressing the P, it accepts that. R is the reset time. Again, this is one of the PID controls. Reset time is the time in the cycle. So the controller is working on a cycle. 9 seconds is what we have found to be the best. CY again is a cycle time. This is another part of the processor algorithm. 1.9. If you take this down too low, you can start to make the machine very twitchy. So by taking it up, you can improve the control, but you're delaying the time between it realizing there's a temperature change and doing something about it. So 1.9 is a sort of happy medium. Press P again, hysteresis. This is the same hysteresis that we saw in the first list of parameters, but it has to be set in this as well. So 1.0 again is the preferred value for that. Y0 is 0. Y1 it will be 100. These are just nominal figures. They don't really affect the control too much. Minus 100 for Y2. DF 0.8. Again, this can make the control twitchy. If your control is twitchy, you just raise that up a little. Raise it up to 1 and then 1.2, 1.4 until you get adequate control on the machine. 0.8 is the factory setting that we put in. For 99% of machines, that's fine. They are all tested here before they go out anyway, and we would make any changes to that were necessary. SP is your operating value or your set point for this particular machine. As all machines that we send out from here, they're set to 37.5. That's pretty much a standard incubation temperature. I know some falcon breeders and some parrot breeders also require a lower set point. That's very easy to do. You can take it down using the middle down arrow or up using the middle up arrow. Press the P again to set point and once more to exit. So you now come out of the program and it's gone back to reading the standard temperature inside the machine. Okay, both the indicator lights are on, showing that the alarm circuit is active and the heater is on. This machine won't go up straight away simply because it takes a few seconds for the heater to get some heat into it, but that's the way to set the parameter up. I'll quickly read through the list of parameters again with their values. So you start off with AL at 0.5, you then have PB at 0.1, you have DT at 2, RT 9, CY 1.9, HYS 1.0, Y0 is 0, Y1 100, Y2 minus 100, DF 0.8, and the set point is of your choice, but we set them at the factory to 37.5.